Brahmos, India's first supersonic cruise missile. So speed, accuracy, agility, lethality. These are the four major characteristics of any missile. Many countries have requested us to export for their use. That is a good sign, good for the country, good for the industry, good for the academy, good for the Ministry of Defense. She has just delivered a baby. She came to know our launch is next week. She said, I have to be there at the launch pad. See, we can always say, India before Kalam, India after Kalam. India is getting ready for the dream of our current Prime Minister Vikasit Bharat by 2047. This is the target for all young people in front of me. I say, please, 2047, decide what you are, where you will be decided today.
Hello everyone. Today's episode is a missile special podcast featuring a legend in India's missile technology, Dr. Prahlada Rama Rao. A Padma Shri Awardee, he's played a pivotal role in India's missile defense, leading projects like Brahmos, Akash and Agni, weapons that put India on global defense map. From becoming the director of DRDL and later a chief controller at DRDO, his journey is packed with leadership, innovation and game-changing defense strategies. In this episode, we break down the science of missiles, India's defense advancement, and the vision for Vikasit Bharat 2047. If you've ever been curious about how India builds world-class defense tech, this episode for you. Let's dive in. Good morning, sir.
Morning, Pratibha. Good, nice to see you
Nice
after
to
almost
meet
an year.
Yes, almost a year.
Yeah.
Let's first start with a very simple question. How has your morning been so far?
Of course, see, we have a regular routine. I have a regular routine mornings. I have my yoga about 45 minutes, walk about another 45 minutes. This is my regular routine. So I finish my routine, then I have my breakfast. I'm fully energized.
Fully energetic for the podcast now. Lovely. Sir, today I'm like a student in your classroom, okay? And I have a lot of questions which I want to ask you.
Yeah, difficult student.
That we'll see.
Okay.
Okay. Before we get started with anything, I want you to give a very brief introduction about like what missile technology is for a complete beginner who has no idea about. Okay, they've heard about missiles here and there on news channels and stuff, but they don't know what it means. How do you explain?
See, students, of course, they keep hearing nowadays missiles, rockets, but they'll be half knowledge, not complete. So I want to put them into a proper perspective. In fact, it's very interesting to know that even in our old epics, people talk about missile which could home on to a noise. Imagine, I was really amazed that if the target which is generating noise, missile Astra, can go on, home on to it and kill the target. This is explained in epics, our epics. So today's missiles are like that. Suppose there is an enemy aircraft coming. I'm talking about at air attack. Air attack wants to come and attack our station, ground station, any place. So it comes, it has a surveillance, checks what to attack and keeps coming to attack. So our purpose is how to defend against such an attack from an adversary. So you have to have our own stations to detect somebody is coming near us, coming towards us, some altitude, speed and direction, and how in what direction likely to more proceed. So at what time I should decide it is an enemy, not a by mistake target, or it is an intentional maneuver some target is doing for a particular mission. Immediately I sense it, then I alert the weapon system automatically. Weapon system gets alerted. Then it looked for all 360 degrees, full altitude bracket, range bracket, azimuth bracket. And then it will tell, okay, there is something happening which is going to a point of interest to us, but the adversary need not go there. So then our action starts. We will assign a weapon for that target, for that and that in that direction, so that it will not be permitted to go and complete whatever mission it came for. So there will be everything automatic nowadays. So the radar is alerted, the launcher is alerted, the missile is powered, waiting. Moment the commander says go, he has to press a button, the missile takes off, goes and annihilates the target. This is the surface to air or air defense. Second is you want to attack an enemy target, that is air to ground or from surface to surface. Suppose you got a target, enemy target, you want to attack, it may be several hundred kilometers, several thousand kilometers. So you know the location by geographical location, you know the altitude, you know azimuth, you know range, you know everything you know. So you launch a weapon to go there and then destroy whatever there you want to destroy. This is surface to surface. It can be air launched. Aircraft will be carrying the missile, air to ground missile. It will go and it will go and attack. These are the very popular. There are many smaller things like anti-tank missile. But these are the major weapons, cruise missiles like Brahmos we are having. Then strategic ballistic missiles like Agni we are having. Then air defense missiles like Akash we are having. And many varieties of that are there. There's a big family of weapons. Because user has a specific weapon for a specific mission on a specific target. He has got all the... So the user demands, Army, Air Force, Navy, they demand, I need such a weapon for protecting the country. Then we have to take action. So this is how it is. So they are all highly... Say, I give the characteristics of a missile is speed, very high speed. Then agility, it can maneuver very fast. Then it will be very accurate. It can go pinpointed. Okay, you want to hit a tank, it will go to where exactly you want to hit a tank. You want to hit an aircraft, irrespective of its maneuver, it will go and destroy an aircraft. Very high precise. And fourth is lethality. You should destroy the target, what it goes. So speed, accuracy, agility, lethality. These are the four major characteristics of any missile. So we ensure that all four are fully complied.
Got it.
Yeah.
Okay, sir, you gave an example about the missiles, right? For example, Brahmos. With that example, can you explain us, like maybe what would Brahmos do? Like in what situations would they use Brahmos?
Brahmos, is India's first supersonic cruise missile. So it goes to 3 times the speed of sound. So it's called supersonic. And then it is cruising. That is, normally what happens, you launch a missile, it will go somewhere and then the propulsion is stopped. Then it keeps gliding, the speed keeps falling, it goes to the target. But the cruise missile means the engine will never stop. So it continuously, like an aircraft, it keeps flying. So the speed of the missile will not come down till it intercepts the target. So Mach 3 will remain Mach 3. So that is a supersonic cruise. Then it has been given a defined target. What target the weapon is supposed to annihilate? Suppose it is a bunker, it may be a ship, anti-ship, it may be a Air Force protected entity like a station or a control center. So it will go there and then it can navigate by itself to near that point. It's called dead reckoning. That means by knowing the geographical coordinates, it can blindly go there. But once it goes near the target, its eye opens. It will check up which is the target, which is the correct target, how is it located, where it located, at altitude, everything. Then the computer computes exactly how to attack and near the target and go near it and explode. All the things are decided by the missile. The operator is, the intelligence is put into the missile. Missile is intelligent enough to do all this work. It will go and destroy the Brahmos. We have seen they have demonstrated anti-ship. Ship is moving, but the missile goes, locates the ship. As the ship is moving, the missile corrects this trajectory, goes and hits the ship. That also we have defined from the sea level at what height the missile has to hit. Suppose you want it is 5 meters above the sea level, above the sea water, it will go above 5 meters, then it will go near through the hull. So accurately it can be done.
How, sir? How can it go that accurately? Like, what is the
That-
technology we are using?
That is we have got the altitude, we have got we know the missile is cruising above the sea surface at what altitude it's flying. So you can set the altitude. Whatever altitude you want, it can flow 2 meter, 5 meter, 10 meter, 20 meter. It will keep on going that altitude. Then the azimuth correct, it will correct and home onto the hull of the ship.
Altitude, though, we can decide because above sea level.
Uh,
But if the ship is moving in different directions,
But it's got a radar. There's a radar inside the missile. It is kept on from the beginning. It keeps looking at it. When the ship moves, the radar, the computer will tell through the radar, the ship is moved to the left. It will move left, or right. It will go right. It's very intelligent. Surprisingly intelligent.
that's very interesting. So there is no operator who's controlling it
No way.
at all.
The operator's job ends the moment he presses the button. Finished. It will go.
Interesting. So, sir, if in case I have to break down this concept on a fundamental concept level, if I have to start learning about missile technology, this is a surface level that you told us. Where do we start? What are the fundamental concepts that I should know? Should I start from aerodynamics or where do I start?
See, the beginning is, of course, intermediate, the foundation, up to 12th standard. That is good enough. Afterwards, you decide what you want to do. You want to do in the missile, that is the propulsion, then the aerodynamics, the structures. Then you have to choose a degree or a graduation in aeronautics. Fortunately, there are nearly 100 institutions in the country who teach aeronautics. So there you can do. That's what I did from ISC Bangalore. I did my master's in aeronautics. Then now aeronautics can be done in VSSC, Trivandrum, they have got then we have got at DIIT, we have got many private engineering colleges. More to the government engineering college, you can have basic degree in engineering, especially in aeronautics, or in mechanical, or in electrical, or in microwave, or in materials. Once you do a degree, then you have to learn on the job how to design a missile. They will not teach you how to design. They will teach you fundamentals of engineering, science related, engineering related. You go. Then when you actually have to design, then you have to, a team is formed. We have a team at every lab, for example, ADE Bangalore, DRDL Hyderabad, RCA Hyderabad. We have a laboratory. We have bring the teams together. See, when Dr. Kalam became the director of the missile labs in Hyderabad, he put a bunch of experienced scientists from the missile laboratories who have been working in the area of missiles. Then he hired 200 young engineers, bright young students, just degree, raw BTech degree. From so many campuses, he went physically, took a team and hired them and put them along with the experienced few people and brand new engineers, few people made team. They are the ones in 1980s he did. Today, 2020s, they are the one who have come at the top of the structure. The other people would have contributed, retired. The young people who joined, now they are all in the prime positions, are directors, are director generals, and they are holding responsible positions. They are taking the country forward. And of course, as all of us know, Dr. Kalam changed the scenario of guided missiles, technology, industry, and academy. All the four. He is the one who he integrated four. That is academics, then the engineering, that is the industries, how they are ready, then the R&D laboratories like NIL, DRDO, CSR laboratories, atomic energy there, and of course the team who were making the missile. He brought them together and made us work with Army, Air Force, Navy. Every missile project had representatives from respective Army or Air Force, Navy. They were posted to our laboratories. We worked together, shoulder to shoulder with Lieutenant Colonel, Commander, Wing Commander. We shoulder to shoulder worked. We know what the user wants. Then we know how to do it because we are using the academic people, innovation. Then we know how to make it happen. So we know industry, they make the prototype. So he brought all four elements together. That is his greatness. He was there nearly some 3 decades. He was there. Fortunately, I was with Dr. Kalam for 3 decades. So we learnt a lot from him, the leadership, the how he will guide us to make the, we have learnt a lot. And I think we have passed on that know-how, the technology, leadership qualities to next generation. So that's how we are able to do some excellent work we have done in the guided missiles. See, we can always say India before Kalam, India after Kalam. India after Kalam is a high-tech country with integrated academy, industry, user, and R&D. It became like that. And thanks to his leadership, we made some very good products. All the missile products, you take Akash, you take Astra, you take Agni, you take Brahmos, you take Prithvi. Each of them had very specific technologies which is unique for that missile, which nobody else has in the sky in the world. So each had some specific parameter which is unique. So therefore, it becomes such a sort of a attractive subject for the Army, Air Force, Navy. Oh, I need that characteristic which gives me superiority. So he took Akash, he took Brahmos, he took Agni, he took everything like that. So we are now fortunate to not only produce for the services, we are also continuously improving for the next generation threats. And as you might have come across, many countries have requested us to export for their use. There are a list of half a dozen countries who are all tapping the door of our Ministry of Defense. Can we get Brahmos? Can we get Akash? Can we get Pinaka? Like that, many people are asking. So this is a good sign, good for the country, good for the industry, good for the academy, good for the Ministry of Defense. It's a very wonderful. And so the students have got a great opportunity. In fact, I feel jealous of young students. When we are studying, there are no charts like that. There are no opportunity for us to do what you say. You want to learn flight dynamics, you don't know what to learn where. But we know now, we know, you know how to go, where to go. And there are a lot of institutions, facilities, software tools, and industry is ready. Many industries are ready to take young engineers. Those days, if you do a BTech degree, you have to take a government job. There are no other. So when I was graduated, I had only two choices. I joined Karnataka State Electricity Board. If I'm an electrical engineer, mechanical engineer, I join HAL or BS, something like that. There are no third option. Only today, students have big variety of options. And wherever they go, they can shine, they can contribute, they can learn, they can innovate. So this is a good sign. And we are in the right ecosystem thanks to the role played by Kalam and work of nearly 3 to 4 decades happened. We are in a good position, and I think India is getting ready for the dream of our current Prime Minister Vikasit Bharat by 2047. This is the target for all young people in front of me. I say, please, 2047, decide what you are, where you will be. Decide today.
And start planning from now.
Start planning and working for it. See, planning we can do. Government plans very nicely, but the implementation is one which is really big challenge. You can plan many things, but don't implement, it will be null and void. So you have to plan, you have to implement. So I am asking them to plan, implement effectively, so that we will have the dream of Indians, a developed nation by 2047. We should all celebrate.
Got it. So you mentioned about exporting the missiles that we build, right? I'm very curious, like, can't other nations reverse engineer what we have built if in case we export? Like, is that a good idea? Like, I don't know.
I agree. See, you have been using a mobile for last maybe 5-10 years. How many have they been copied? Very few, very few. Because if you want to copy anything, you need a lot of infrastructure, a lot of knowledge, a lot of industry support. You can't simply, it's not a one-to-one copy. So if anybody wants to, suppose one country buys Akash missile, if they want to remake, they will take 10 to 15 years.
Is it?
Yes, it takes 10 years minimum to make a new missile, same as Akash or better than Akash. They will take 10 years. By the time I would have made next generation. So this is what happens. Nobody can emulate, copy a high-tech product requires so much of knowledge, engineering, science, and effort. It's not easy to copy. That's why people are. And also, see, you can understand there are a lot of some smaller details of the missile which will not be easily noticeable, which will not be documented, and which will be known to only the original designers, and that is why it becomes self protected automatically. It can't be easily recognized, and is not written down. So some very fine, say for example, you are talking of electronic warfare, the frequency, the pulse weight, the pulse shape, the pulse repetition, so many factors. You may not give all the details in the hardware. You know there is a transmitter receiver, but all the details will be in the system software which we have written. So they will not be able to know what it is. Like a you want to make a biryani from textbook. The biryani won't be never as good as an expert making biryani, because it's always some small details which will not be is a software inside.
Got it.
That's what happens.
Interesting. So okay, let me think that, okay, today I'm going to start building a missile. How would I start the designing process? And how do I think about building it and how do I launch it? Like the
See,
things.
what we started, I will tell you, when we all started as young designers. First, we said the who wants this missile? Say army. So we invited army. Please give me your requirement. So you give a document. Then you tell us what you want us to make. So you understand the user requirement, the most important. His every word I should decode and understand what range he wants, what weight he can accept, where he wants to deploy, high altitude, low altitude, desert conditions, then what speed he wants, how much time he has got to detect an enemy, how much time he has got to destroy the enemy, how much allowed, then what is the size of the enemy target? Is it a small hut? Is it a big building? Or is it a vast area? Depending on that, the warhead has to be designed. So if it's a flying target, it requires a small warhead, smaller but highly lethal. If it's a big target, like a big large area, don't need a big warhead of several hundred kg to go. It's an area weapon. So depending on the user requirements, once you understand, so you start designing a vehicle. What vehicle? First is propulsion structures, and the aerodynamics will be the first major. The electronics will come inside. Last will be the software. What software will go is the last. So we design the propulsion, we do aerodynamics, we design flight dynamics, the structure it carries, then the ground system, how to launch it, how to direct it, radar required, launch required. Then the software, the intelligence the missile should have when it is flying to complete its mission, what we have defined and put in the computer. So that software we have to code and keep. That will be the biggest secret of any weapon is the software inside, which will not be given to anybody. That will be only embedded, like is a code embedded software, and it cannot be decoded. It is all in the other. It's not in a code. The code you can decode.
Is there like an intellectual property that we define?
No, we have we see for a missile there is no IP, but for various technologies there is IP. Suppose you make a algorithm for detecting a moving ship. There is a algorithm we develop. We can patent it. We can patent it and protect it. And the missile when we give we sign what is known as a non-disclosure agreement with any customer. So he has to give in writing. His government has to support that the any detail what we have got from this hardware will not be shared with anybody else. He gives a oath and gives, and we also take care. He also take care. It will not be made available easily to anybody. So that agreement is signed, and if anybody violates the agreement, we will know. Then we can take either punitive action or preventive action or correction we can do.
Okay.
All are possible.
And you worked on so many missiles through your career, right? What is one of the most difficult problems that you have faced when it comes to missile tech?
See, because I was the project director for Akash, and program director for Brahmos. This I was there. So naturally, I'm a little biased also. But when the Akash missile was given by the Air Force and Army, you make a missile which can see the characteristic given by Army and Air Force is you should be very fast, minimum Mach 2, number one. Number two, you should be very agile. You should be able to outmaneuver any target. The fighter aircraft comes, it can also maneuver. You should be able to outmaneuver. That means my maneuverability of Akash missile should be more than maneuverability of the enemy fighter aircraft. Enemy fighter aircraft, there is a pilot sitting inside. So he can't maneuver beyond some number because otherwise pilot will want sustain. I know what maximum he can, which is called G, how maximum G he can pull, say 5G, 6G. Then I make my missile to 18G, 20G like that, so that my missile can outmaneuver. It's like a one-to-one fight. So he maneuvers, I outmaneuver. So then speed I will catch up. Whether I am chasing him or I am facing him or side attack, I can outmaneuver. Speed, agility, and warhead size. See the accuracy. See the aircraft and the missile are moving towards each other. The relative speed is anything from 200 meters per second to 2000 meters per second. It can be. So if it is 1000 meters per second, that means every second it moves 100 meters. So how do you accurately define when they come very close within a few meters and I have to explode my warhead? It has to travel so many meters to hit the target, and the aircraft should not miss it. It's a very, very precise control, precision, mathematical modeling, and understand the dynamics of the weapon, that is the missile, dynamics of the aircraft, dynamics of the warhead fragments, all should be understood. They are all to be calculated in terms of milliseconds. Milliseconds accuracy I should be able to hit. Then only the destruction time. So it was the biggest challenge when we faced. And we were not sure, we were all young people. I was just in my early 30s when I started doing this. We were not sure whether we can make a missile of this complexity in this country. And in addition to that, the Air Force and Army said, see, we expect 4 targets, it is 4 enemy aircraft, to come from 4 different directions, from 4 different altitudes, from different speeds. You should kill all the 4 simultaneously. This is the challenge they gave. We were scared. How can I do it? As on that day, in 1980s, we were only seeing 1 missile, 1 target. At the most, 1 target, 2 missiles, in case one is. He says, no, 4 targets, you fire 8 missiles. 4 targets, 8 missiles. You want 12 missiles, 4 targets, 12. I want all 4 targets to be destroyed. 100%. So the kill probability will be extremely high. This is what we were told. So we were really driven to the wall. How do we do it? Fortunately, for a wonderful work done by nearly 1,000 engineers have worked for about nearly 15 years all over the country. All the DRDO laboratories, industries, academics have contributed. We made a success. Today it is a big success and it is doing its job exactly the way Army Air Force wanted. And they were so impressed that many outside countries, they said, please give it to us. We also want it. So Government of India has to take a decision depending on which country, whether we are aligned to them, they are aligned to us, then only we can give. We can't give to anybody. So the government decides. Right now we are talking about 3-4 countries are showing interest for Akash. It's a big challenge. Brahmos also became, because Brahmos, as you said, the ship is moving, is not stationary. Anti-ship. Ground targets we know stationary. Then ship is moving, and ship is so low, it's just above the sea level, 3 meter, 5 meter. To make a missile keep flying at 5 meter above the sea surface, it's not a joke. It's very tough because sea waves are there. The ship also is heaving, the same waves are moving, and your missile has to go without losing the altitude accurately to fly. And the ship is moving. We don't know in what direction it can move. and you are having a flight time of several minutes. In that, ship may just try to move away because ships can high speed ships are there. So there's a big challenge, and fortunately, everything was done. It's a supersonic. Now our speed is three times the speed of the sound, whereas the ships move relatively low speed. It is very much low speed. So the missile goes so fast, missile goes so low altitude. The enemy radar inside a ship cannot detect this missile because it is so low, it is below the so-called below the horizon. See, radar is on, but they don't see anything because the missile is so low. And by the time he sees, he is just almost he is in front of the ship. The missile will be about to hit the ship. So by the time the radar notices it, it's too late. So it was also a big challenge. So these two, from my understanding, knowledge of science and technology, biggest challenges are these two missiles, and both have been successfully done. Both have attracted multiple nations to seek from our country, and I'm sure recently, when the Prime Minister of Indonesia came, our Prime Minister, they had a one-to-one talk, and they agreed to deliver some Brahmos missiles. So this is a good thing. It's good for the industry because they are business. Good for the country, our knowledge, prestige. Good for the technologies who made it, so can make still better.
Much better.
And good for many views. Is a very good progress. What happened India in 2020 when compared to India in 1980s, what a big difference it has made. We have seen, I myself have noticed 4 to 5 decades of the nation's progress.
Got it. When you spoke about the precision, sir, I was just remembering in mathematics when we studied in 11th and 12th, we had that figure called delta. What is this? What is the degree of precision that you're operating with? Plus or minus delta. So for the missiles, what is this plus or minus delta that you
No,
feel?
there is no delta there. Missiles, we use a different terminology. We say, for example, if you want a ground target, we say what is known as circular error probability. Big, you want to attack a big ground target of several 100 meters, say 100-meter target. Then the missile will go to the target, circular error probability. That is, the probability the missile will be on the dot center point is 99, they will put 75%, 85%, 95%. That accuracy, within that percentage, it will be there. That we demonstrate both through mathematics, simulation, as well as through flight tests. We conduct number of flight tests to prove what we have put in my specification is really met.
Got it. And these are all very big scale, large scale scientific projects, right? And like you said, there are multiple stakeholders involved, be it like Army, Navy, and also the scientific group. How do you manage? Like, how do you get all the inputs right? Because, for example, from Army, let's say, what is the sample size of people that we are taking inputs from? Because maybe we're getting one input from one side and then there is a course correction eventually, because of which there can already be some progress which is made. How do we make sure all of that does not happen?
See, this is where I learned from him called leadership. See, when we were working, I have told you, nearly 1,000 engineers work from different parts of the country. There were professors, there were industry experts from like L&T, Godrej, people working. There are laboratories, DRDO laboratories, 20 laboratories are working. Somebody will make warhead, somebody will make propellant, somebody will make electronic, somebody will make a mechanism, somebody will make a explosive. So we have to take 1,000 people to be aligned to the purpose of the project. Okay. That comes from the leadership. Now, the qualities of leadership was what I picked up from Dr. Kalam. One is, nobody is a dud. Nobody is zero. Everybody has a strength. Maybe analytical, maybe design, maybe communication, maybe calculation, maybe modeling, maybe simulation, maybe actually performing the machining. So everybody has a strength. So recognize the strength of every individual in your team. Suppose you made a team of 500 people, you know strength of everybody. Then give that person the job which will be suiting his strength. Try to mix and match. Then recognize what he has done. Encourage him or her and recognize and see how they deliver. It is amazing that once you do this, there is a two-way communication. The person who is doing knows the person who is my leader is committed. He wants this to be done in the interest of the country. I have to do it. And the leader knows I depend on this person for the mission accuracy, repeatability. I have to give due respect and due recognition. See, once these two people match, wonders take place. See, I will give a very small example, which is very moving, touching. We are all doing testing of what is known as a radio fuse. We want to test it, realize how to test it. We were having a lot of problems because I told you when the aircraft and the target is coming, we have to know it is from the missile to a target is 30 meter, 27 meter, 25 meter, what direction, at what speed that is moving, what speed I am moving. Everything should be very, very accurately measured. And the whole thing is done in milliseconds. And you are not seeing the fuse range itself is 30-40 meters. So we were asking one young lady scientist was the one who designed that proximity fuse. And we all went for launch. It took some time, some delays. Finally, we went for the launch of the verifying the accuracy of the fuse for detonating the warhead. We went to. No, what happened? It got delayed. Finally, the day we fixed the launch, this lady had undergone delivery of her first baby. She was in the hospital. And probably 1 week later is our launch. She has just delivered a baby. She came to know our launch is next week. She said, I have to be there at the launch pad. Then doctor said, Madam, you are just a baby. I recommend you not to go. She said, no, sir, my baby is there. I have to go. Then doctor didn't know what to do. Then doctor called her mother. See, this lady wants to go. She said, don't worry, I will carry the baby. I will travel along with her from hospital to that place and bring her back if she's using. So the mother, the daughter, our engineer, and the baby were brought to the launching complex. They were put in a room, and when the countdown took place, we brought her to come to the place, sit for about 1 hour, and then we are all surprised, Madam, how you are coming? Says, my baby, that is my baby with my mother, this is my baby I have done. I have to see, it cannot fail, I want to see. So it's such a touching moment, and we really moved. See her commitment. She need not have come. She said, I have done it, my job, let them verify. But she said, no, I have to be there. If it doesn't work, I should know how it did not work. If it worked, I am happy it worked. So she came, she stayed for a day and she went back to her hospital. This is the commitment. This all comes because of the leadership. She believes in her leader. There's a mutual trust, mutual commitment, mutual respect these two people have. If that can be generated, wonders can take place. We have done what we could not imagine we have done. All these systems, what you've seen, is very, very big challenges. And only those who have really gone through, like this lady I told, they can appreciate. Outside, we will not be able to appreciate. They think once you see everything working, press a button, it works. Oh, everything fine. But what is the hours and days and weeks and months and years of thinking, calculation, failures? Oh, it's a big learning. But we have learned a long way, and this relationship is respected, we can do wonders. I think we have enough capability in the country, but we have to match the capability with the task. If you put the wrong capability for wrong person, it won't work. This is the situation. We have to recognize this matching.
And in terms of leadership itself, so one question that I have is there is something that a leader has in mind. How do they make sure the entire group of people, like let's say it's going to be 150, 200 people, for example, if those many people are working under you, how do you make sure the culture is maintained throughout? That's
See, leader keeps talking to people at various forums, and for example, we were having a propulsion test for a ground. Somehow it became late and we had to do a test there. So when we really tested the engine, it was night 9 o'clock, something like that. But that test did not go through, it failed. The motor burst, exploded. Night 10 o'clock. Dr. Kalam was there, I was there. We did not know what would have gone wrong. Night 10 o'clock, whole work day. Then he said, no, don't worry, let's all sit for half an hour and discuss what. So night 11 o'clock we are sitting on a place where the motor has been burst and all, and try to find what are the possible reasons why it has failed. So we up to midnight we worked out, listed 1, 2, 3 possible reasons. All scientists were sitting nearly 20, 30 people sitting at night, midnight, trying to list why it has failed. And then found, I said, next time we'll see that none of them will occur again. We have to solve each problem. So next time we'll see, once such a interaction take place, people have a lot of respect. They know, no, we cannot fail. That comes. So once you do that, the leader, the communication is so clear, he did not say anything. Let us review, finished. The attention, the commitment automatically flows. I don't have to tell it. So this kind of experience, many are there, but we have to. Even now, I am in touch with all the scientists from Brahmos, from Akash. Uh, so there is a mutual respect, mutual appreciation, recognition, and they all say, "Sir, I know how much we struggled, but we see Republic Day parade." My said, we are very happy. This is the. They give a ring. Republic Day going on, I'll get many calls. Sir, I am watching today's parade. So that is a big thing, and it will be lifelong relationship.
Got it. And you've had a long interaction with Dr. Kalam, right? In terms of leadership itself, would Dr. Kalam lead by example? Like, would he connect with people more often? Like, what was his leadership style like?
That's what I'll do. He is one who believes in everybody's strength, number one. Number two, moment you are strength, suppose you are good in simulation, he will see that all simulation tasks come and talk to you, and tell you how important it is for the project that your simulation should be properly done. He will take you to the height, what he calls, no, don't think small, think big. So when you are doing, you are thinking only big things. You don't think small. Oh no, I didn't have my lunch, or just such things are not the issue. Issue is you want to achieve this target. How do we achieve? This is the type of a commitment they expect, and that has been our hallmark. We all shared our the ultimate goals. We shared. That's how we could convince people, deliver things, and also, for example, I'll tell you. Suppose there is a good this one meeting success. There's a meeting success is there. Uh, he is going to Delhi to meet the minister. He will take the guy who was responsible for the good success. He will say, "Sir, I want you to bring one guy who has made this happen." So to the minister, you will take a young scientist, medium scientist, just introduce the minister, that's all. Yes, sorry, you've done a great job. I mean, without him, it would not happen. That's all. He did not say anything about his background, nothing. He says, I brought him just to see that he is the one who changed the success. This. Once it goes, you can see what it rejuvenates the whole team. Rejuvenates the whole team. He did not go alone and say, I got it done. He said, this fellow has done. I have brought you to meet you. See, there's a difference. He could have told the minister, sir, I got the big success done. No, he said, this guy did. It was successful. I brought him to show you. He's the guy who has done. Then the whole life is dedicated to the organization. There are many examples like this, and I think it has served its purpose, no doubt.
And has there been an instance when probably you were trying to solve a problem and Dr. Kalam has given a different way of thinking for the same question that you had asked?
No, see, he's a great fellow. In a meeting, A person can ask a question which is not in line with Kalam's thinking, but he will never take it as an offense. Oh, you are suggesting. Oh, let us think. Let me see. Why not? Maybe we can have a relook at it. Then he will ask somebody, hey, he is bringing a new way of looking at it. What do you think? He may say, yes, sir. He may say, no, sir, I don't think it will work. So he will never, I have never saw him losing his shirt. He will never fire anybody. He will never get upset. If there is a failure, talk, or somebody has literally told him what you mentioned is stupid, he will not get upset. Maybe what you say there may be some truth in it. For me, it may look different, but I respect it. I will look at it. I will analyze it. And many times he has invited so-called people who would have treated him without, trust. He said, "You come for review. You will not call for review." See, normally what happens when you want to review, you call the people whom you know, who will be, in line your thinking. He will not. He will think who can create the questions, who can say what are the likely problems. Call them, use them, find solutions. This is my job. My boss is the project. For a project, I can call anybody. My enemy also, I don't mind calling, because for me, success, my project is my ultimate goal. Not that my success, the project success. So if my boss is my project. If my project succeeds, I succeed. For project success, if somebody has to come and review, he is maybe not liked by me, but I will call him, because he can give me the clues. So he used to call people of that. I have also called many people, and called people who would have not, they will say, this fellow is not very, not in the normal boundary conditions, he goes beyond. Doesn't matter. The purpose is served. You should not. If that is the objective, is what drives, not the subjective. If you go subjective, everybody realizes the issue. If it's objective, people keep quiet. This is what happens. He was always objective. We learned from him. What is the objective? Meet the objective.